Okay, welcome back. What I want to look at today is cable calculations. Okay, and this is something that you will need to be able to do in due course. Okay, design procedure. Now, when we say design procedure, we're looking at your design current. Okay, determine the design current IB. Determine the design current IB. Okay, select the rating of the protection IN. Select the relevant correction factors CF. Divide IN by the relevant correction factors to give IT, current total. Okay. Choose a cable size to suit IT. Okay. Check for voltage drop. And again, always check with the IEE regulations that the percentage of voltage drop is at the current rated percentage for the period of time in respect of the relevant edition of the IEE regs. Check for shock risk constraints. Check for thermal constraints. Okay. Now, here we are now at the design current stage. The calculations for IB is IB equals P over V. P stands for the power, V for voltage. Now again, please note that this would be written some time before, so it'll be IB equals P over U, okay, for current status of voltage. And IB equals P over the square root of 3 times VL. Okay. Now, nominal settings of protection. Using the value determined for IB, we then select the value of IN, IEE regulation tables. Now, the IEE regulation tables is consistent, and you will need to look at that for the current edition of the IEE regs, allowing for any changes which may have taken place in due course. Okay. Correction factors. When a circuit runs at full load, it generates heat. To compensate for this and protect the insulation, we need to apply correction factors. Okay. Ambient temperature, IEE regulations based on ambient temperature of 30 degrees Celsius. Okay. Now again, confirm with the IEE regulation that it is current and there have not been any change to it. But the 30 degrees gives me an idea that of any possible change you need to take into account. Okay. Temperatures above this need a correction factor. Okay. Grouping. Now when we talk about grouping, we're talking about grouping of cables. When cables are grouped, the heat generated can be passed on to all the cables within the group. Table 4b gives allowances for these factors. Okay. Right, BS3036 is a fuse, a semi-enclosed fuse to be precise, rubber type. As discussed previously, has a high fusion factor compared to other types of protective devices. When using this type, we need to apply a correction factor of 0.725. Okay. Now, thermal insulation. Virtually all new premises use thermal insulation as a means to conserve energy. Appendix 4 of the regs covers cables run on one side in insulation. However, tables 52A should be applied if it is totally surrounded. Okay. How to apply factors? If a circuit is protected by a BS3036 fuse, then the factor 0.725 always applies. If a circuit has more than one influence, such as the example below, then the worst case only need to be considered. And they're looking at grouping factors 0.7, high ambient temperature factor of 0.97, okay? Thermal insulation factor 0.5. So all that will need to be taken into account when you are considering the relevant current and effect upon the cable. Okay. Current carrying capacity, right? The required formula for calculating current carrying capacity is IT, well, represented by greater than or equal to IN over correction factor CFS. Okay. And again, don't forget this is your correction factors. Example, IT greater than or equal to IN over CFS. IT equals now your 32 amps comes from here, your miniature circuit breaker, okay? It's an MCB. And your 0.5 is your thermal insulation factor, okay? And that gives you 64 amps, okay? Example 2, IT equal to IN over CFS. IT, now the main fuse here is a 30 amp BS3036. And you're looking at 0.5, and because it's BS3036, you also have to take into account 0.725. Okay, so you can see that here immediately there's an increase in the amperage, which means that cable is going to be carrying a lot of current and getting very warm indeed. Okay. Now again, remember you're multiplying that by that and dividing that by the total factor of this, which should give you 82.75. Okay. Feel free to use your calculator to make sure you understand and you arrive at that concept. Now example 3, now CA times CG equals 0.97 times 0.5. which is your thermal insulation factor. Okay, equal 0.485. That's where that 0.485 is this, and 0.725 is applicable because it is BS 3036. Okay, and again you can see we still have a high current rating. Now be familiar with CA, CJ, etc. in regards to the IE regs. They are quite clear and they tell you exactly what they are. Okay, that is your business to know and to find out completely. Okay. Choice of cable size. Appendix 4 of the IE regs lists all cable types and the voltage drop. Example, PVC insulated single phase cable run in conduit having a current carrying capacity of 45 amps installed by ref method 3 table 4a. The table is 4D1A, well 4DIA, well 4DIA, and the column is 4, hence the cable size is 10 millimeters square. Okay. Now the voltage drop maximum allowable is 5% of the nominal voltage for in standard circuits and 3% for lighting circuits. So you can look at this and calculate these. So I'm going to leave that for you to do. Okay. So you look at maximum allowance is 5% of the nominal voltage for in standard circuits. So here, lighting circuits. Well, they're all lighting circuits in this case. But for this purpose here, you need to look at 400 at approximately 5% and 230 volts at 3%. Okay. Voltage drop formula. Now, millivolts amps per meter is from tables in the IE regs. IB is the design current. L is the length of the circuit in meters. Okay. And this is your formula. Now, on average, your voltage drop example, the voltage drop on a circuit supplied from a 230 volt sourced by a 60 millimeter square 2 core cable, 23 meters long, clipped direct, and carrying a design current of 33 amps will be the millivolts from table 4D2B will tell you this. So here is our formula. Okay. VC voltage drop we're looking at equals 2.8 times 33 times 23 over 1000 equals 2.125 volts. And that should fall within our parameter of approximately 3% voltage drop. Short widths, the earth fault loop impedance should not exceed the values given in part 4 of the IE regs. Okay, and again, make sure you're compliant with the requirements of the IE regulations in regards to shock protection. Okay, thank you. I hope you found this useful. Have a good day. Bye bye.